Hey guys, welcome back. I have another video about SAT stuff. Just in case you're new here, my name's Percy. I've been going over SAT advice for people in person and in groups for the past 8 years, and now I'm starting to make a bunch of videos on them. So if you want to see some good content and get some good advice about how to test on the SAT, subscribe to my channel, like and comment with whatever questions you have. So now let's dive into it. Okay, so I've talked about Desmos before on the channel, but today I want to talk about the things where you can just type them into Desmos and it just spits out the answer, right? So Desmos, in a lot of ways, is seen in a delayed gratification sense and an instant gratification sense. So the delayed gratification that I'm talking about is you maybe use it as a tool to graph things along your way to solve a problem or to find an answer. But Desmos can also be used in a lot of sort of instant answer ways, especially on the SAT or for those of you taking certain algebra classes where they permit the use of it. So this first one that I want to talk about is single variable equations. Okay. So a lot of times you're given a single variable equation on the SAT. It could be of any form, right? It could have x or x squared, or it could have the square root of x with something in it. It can be an exponential equation too. The point is, if you type any single variable equation in to Desmos, it will solve it for you instantly. And that's really, really good stuff to know. But you can do this in two different ways. So the first way is you can type out the equation as is. You can say, okay, well, this left side equals this right side. And what happens is your X answers or your X solutions are going to show up as vertical lines that intersect your X axis somewhere. So let's just say you type an equation in and the answers to it are, maybe you get multiple answers. Like the answers to it are 2 and -4. The way they'll show up is as vertical lines that are hitting your x-axis at both 2 and at -4. So that's one way to type it in. But another thing you can do is sometimes those vertical lines, they'll hit a particular part of the x-axis that's harder to click on. And for some reason it doesn't show up when you try to click on it, the number doesn't show up. And so if that ever happens, the solution to that is you take your original equation, right? You set in one of your Desmos boxes, you set y equal to the left side of the equation, right? And then in the second box, you set another y equal to the right side of the equation. So long story short, y equals left side of the equation in box 1, and then y equals the right side of the equation in box 2. And what you're dealing with there is now a system of equations. And where system of equations work is you just find where the lines or the graphs overlap each other or they intersect, right? And those intersection points are always going to give you an x coordinate and a y coordinate, which are effectively your x value answer and your y value answer. They may ask only about the x or y, but just let the question that they ask you determine that, whatever's written in front of you. So those pretty much get right to the chase of just spitting out the answer, right? And so, and I've already addressed this, but even a system of equations problem, even if you didn't have it in the y equals format, right? Like you know, like on your TI-84 calculators, you have to have y equals something, or it has to be in the y equals everything else kind of form. But on Desmos, you can type in the equations even if they're in a different form, like if they're in standard form or something, right? It doesn't have to be in the y equals format. So with any type of system of equations where they just ask for, you know, what's X or what's Y, or maybe they ask for a combination of X and Y, right? All you have to do is, again, type the 2 or 3 equations into your Desmos and just find where they intersect. And that's all you have to do. That'll start giving you the solutions right away. Another thing that relates especially to linear equations on the SAT is going to be inequalities. And what inequalities do is if you type your inequality symbols into Desmos, when you type the equation in, you'll see a whole area of the graph shaded, right? So just keep this in mind. If you have a greater than equation or just a less than equation that does not include the or equal to part of it, that's going to show up as a dotted line, right? Where the line actually exists, where the equation normally would be, that's going to show up as a dotted line. But if you have an or equal to kind of situation, a less than or equal to, or a greater than or equal to kind of situation, it's going to show up as a solid line, right? But in addition to the dotted or the solid line, you're going to see a whole region of the graph shaded in, like I was saying. So basically, when you're dealing with a y equation, like an equation that involves maybe just y or has y and x in it, expect any of your greater than equations to shade the region above your line, okay? And then if there's a less than version of a y equation or a y and x equation, it's going to shade in the area below your equation with whatever color that Desmos chooses. And the only exception would be if you have just an x equals a number equation, which is typically a vertical line. Um, if you have x greater than or equal to something, it's going to shade in the area to the right of that vertical line. And then if it's the less than or equal to version, it'll shade in the area that is to the left of x, that vertical line. And just keep in mind that you really can do this with all types of functions too. You can graph absolute value functions, exponentials, quadratics, linears, whatever they go over, right? And so those are typically the main four that they go over. But one that people forget about a lot of the times is a circle equation. So again, so this isn't really a function because circles, they don't pass the vertical line test, but it is an equation that you can graph, especially in the center radius format. You can graph that on Desmos and see the circle on Desmos, and you can see, maybe key points that it intersects, or maybe they're wondering, like, oh, well, which circle equation intersects the x-axis only once? So it's like, okay, well, I can just go through A, B, C, D, and whichever picture intersects the x-axis at one point, that must be my answer, right? So it's all these really instant things that I wanted to go over. And another thing, speaking of functions and things that you can graph, is you can also show transformations on Desmos. You can graph an original function, and then maybe a transformation that they give you tells you to go 2 to the right or down by 7. You can start applying those into the graph and or into the text box on Desmos. It'll show the transformations in the graph. And there are many cases where I've seen SAT sections, they have a problem that gives you a graph, and then they say, okay, transform it this way and this way. And then your answer options A, B, C, and D are all graph related. Okay, so that's going to be something to look into. You may want to graph your functions so you can see how they look when they are transformed. Keep in mind, too, that word problems tie directly into this. If you can generate an equation or some type of expression that comes out of a word problem, like maybe they're doing one of those system of equations word problems where they're selling, a vendor stand is selling burgers and hot dogs. That's two different things, right? Maybe burgers represent X, hot dogs represent Y. As soon as you translate your word problem into two different equations, just graph those equations, and they are likely going to ask about the solution for X, which is maybe number of burgers, or the solution of Y, which is maybe number of hot dogs. So just know that there are tons of things that you can chuck into Desmos. One more thing I wanted to hit on is that you can also apply tables into Desmos. So you can click on the plus sign way up in the upper left-hand corner above the boxes. It gives you a little option to click on that says table. It makes the table, it gives you an X and a Y column, and you can just start typing in all the coordinate points that they give you. And as a matter of fact, a lot of the problems where they give you a table, they'll ask you to turn the table of points that you have into an equation. And one easy way to do that is, firstly, just click on the plus sign, gives you the table. You can copy down all the points that they give you. The points actually show up on the graph, right? So as you make the table, you'll see the points in the pattern that they're starting to head in, right? So because maybe it's going to be a linear or exponential trend. Okay, so then once you have the table, though, you can click on the little regression button that has a line going through points. It's going to be located right next to where your table is. You click on that, it gives you a little drop-down menu of linear versus quadratic versus exponential regressions. And whichever type of function, like linear, quadratic, exponential, that they're talking about in the problem, you can apply, like, let's just say they're asking about, oh, we want to know what type of exponential equation or regression goes through these 3 points. What you can do is just click on exponential regression, and it'll show you the equation below your drop-down menu for the regression types, and that could potentially it just spits out the equation answer for you, right? And what if there are constants involved in the equation? If you have A and B, or maybe like A is the front number, B is the number inside the parentheses, and then you just see the equation pop up on Desmos. You're like, oh, well, I guess that front number's A and then that middle number's B right there. So my point is use Desmos on all these questions to get instant answers. Okay. Because there are a lot of other ways to use Desmos, a lot of other great tricks with it, but these will cut off so much time. These are your biggest time savers and will allow you to have more time when you go back through to potentially, just spend more time to think about the difficult problems that you're having trouble figuring out how to even start. Right. So I just think this is a really good thing to do. And I will continually put out more Desmos related content and also non-Desmos related content. So like I said earlier in the video, like and comment with any questions you have, and I will see you in the next one.